Hello there and welcome to my next tutorial in making a vehicle in Godot and making a car specifically. I've looked at the Godot documentation and found this vehicle node and thought I'd play around with it for a little while. So I just put together a simple scene, and in this video we'll go over some of the ways that I managed to get this. We're going to keep it simpler than you see in the video in front of me right now. It took a little while to set up a bit of a fancy model and the environment that I've got from the Cinti Studios. So it's a pretty cool node. It works really well. What we're going to cover is we're going to cover the vehicle body, and we're going to cover the suspension. You can see that it moves around with suspension and damping as you go over the different bumps and lumps. We can change it to make it as realistic as you want. It's got a proper tyre model with slip and slide and amount of grip. It's a really grippy one right now. But yeah, hopefully this tutorial won't be too difficult to follow. It's a pretty cool node, and I haven't seen it anywhere else on the internet, so I thought I would just quickly put together something to show people how to create a vehicle using the Godot vehicle body node. Alright, so I'm starting with a brand new blank empty project with nothing in it. I'm going to call mine Car 3D. I'm just going to create this and get started. So we're going to need a brand new 3D scene. I'm just going to call this game as this top level spatial, and then we're going to add the things that we need to this. So first up, we probably want to add a ground so that we can drive around. So I'm going to add a child node, and I'm going to add a mesh instance. That mesh instance, just quickly rename that to ground so I can get myself organized. And the mesh that I would like is, I'll just use a cube mesh. I'm going to click on the cube right here and make it quite a bit bigger. So I'm going to make it 50 by 1 by 50, just so that I've got a nice space to drive around on. And before I forget, it's probably a good idea if I save this scene. So I'm going to save it as game.tscn, and so just so I don't forget. Let's add the vehicle in here. I'm going to create everything in this one scene, and then we can dish them out into their own scenes once we've got ourselves organized. So I'm going to right click, I'm going to add a child node. We're going to look for the vehicle body. So this vehicle body is part of the rigid body, so it contains all the physics that you need. There is some information in the documentation, but I'm just going to run through most of the things that I've found as I've been doing this, because there's a few little quirks. So I've got this vehicle body, and I'm just going to move it above the ground slightly so that it sort of doesn't hit into the ground, and we're going to create the parts that we need for this vehicle body. You'll see that there's a little exclamation mark saying that there's no shape, so it can't collide. So we're going to have to create the parts for this vehicle body before we worry about the code for it. So I'm going to create the another mesh instance that's going to be, to begin with, it's going to use just a simple cube, just so we can get this thing up and running. And obviously this is going to be the car body. I'll call this car body mesh, and you can make sure that you can use any mesh that you like for this. So you can make your own car model, or you can download something from the internet. This car body mesh, however, does need some sort of collision. So if you download one from the internet, you can create the collision, or you can just do it here. So I've got this car body mesh. The mesh type we're going to have is a new cube mesh, and we're going to make it approximately car sized. So I've clicked on the cube again. So I'm going to make it 2 meters wide, seems about right, and maybe half a meter high, and maybe 4 meters long. So this is in meters, and you can tweak this as much as you like, and you can tweak it when you've got if you have a mesh instead, you can tweak it as much as you like, but it should be approximately car sized or slightly smaller. The bigger it is, the slower it seems to move. So if you have it a little bit smaller than your average car, then it's probably going to be fine. In fact, I'm going to do that and make it 1.5 and 3, so it just looks slightly smaller than your average car. The mesh itself does need some sort of collider. So if I click on mesh, this is what you would do if you had like a more complex mesh. I could actually just give this a box collider right now and it would be fine. But we can use this mesh menu to create a tri-mesh collision sibling. So I'm going to use the convex one because I know that it needs to be. It's going to be a moving. A moving rigid body, not a static. Could use tri-mesh if it was static, or the static tri-mesh here. But I'm going to use a simplified convex collision sibling, and that's the collision shape now that matches this shape, and that will make sure that we do collide the way that we need to. The next bit we want to do is make the wheels, but what I'm going to do is just change the color of this mesh. It's really difficult to see, so click on car body mesh here. Just go down to materials. I'm going to make a new spatial material and click on the material so I can change its albedo color. I'll make this one red. The wheel is going to be part of the vehicle body. If we just click add child node, and I've already been playing with this, so if we just type in wheel, we'll get this vehicle wheel, and we'll just click create. Now the forward direction for the car, the camera forward direction is like the negative Z, but for the car the forward direction is actually the positive Z. So this vehicle wheel, I'm going to rename this as front left wheel. If I can spell, let's maybe do that again. There we go. Front left wheel. And we're just going to move it to the front left. So if I click on the Y at the top, so remember that the front is actually the positive Z, so I'm going to pull it down this way till it's about approximately there, and then move it out this way till it's approximately, so it's going to be just outside of the edge of this wheel. They recommend, Godot recommends that you set it to its highest point, and so you actually set the position of it to its highest point, and it will actually drop down a little bit with the spring. So I'm just going to leave it around about there because I'm not going to have the spring length going to be too big. The blue line that you see around here is the radius of the wheel, and the default radius is actually pretty massive. This is like a monster truck sized wheel, so you can actually set the wheel values just over in the inspector over here. So one of the things that you probably want to set is the radius. So it's a full meter in diameter, so half a meter radius, and that seems to be like way more than it needs to be. It's more likely it's going to be something like half a meter across, but because we want it to kind of like fit your model, you'll just have to tweak it as much as you like. So I'm going to make mine maybe 0.4 so that it's slightly bigger than the height of my vehicle. There's other values that I need to set over here. Interestingly, when you go through these values, the default values that they set are actually well off. If you can hover over some of them and see things like stiffness, it says here that values between 50 and 100 for a race car, so 50 for an off-road and 100 for a race car, but the default value that it gives you is 5.88, which is weirdly precise and doesn't make any sense given that it recommends between 50 and 100. So I'm going to put mine at 50, and the travel is how much the suspension will travel. And again, if you've got like a rest length of 0.15, that's like 15 centimeters. You don't want a 50 centimeter, you don't want it's a really big travel, and you really don't need that one. So I'm going to put it around about the same. So I'm going to say 0.25. I'm going to make this this rest length the same of 0.25. And then you'll see that the spring actually it grows up like that, and we'll see the effect of that later on. The gizmos are quite good because they show you the direction of travel as well. The last important thing that you need to set for that actual wheel is what it's going to it's going to do. So this vehicle body motion, you can see that the front wheel here, you can choose it to be used as steering and you can choose it to be used as traction. And to begin with, what we'll do is we'll just set them here and we'll just get it working. So this is a front wheel, so I'm going to say use as steering. I'm also just gonna just check these values. So I put them, I eyeballed it and I said 0.952. So if I make it 0.9, that'll bring it slightly closer in, and that way I can keep it symmetrical because I can have a negative 0.9 for the other one as well. And we'll give this a value, say 0.85. And that way we can use similar values when we are moving them, so we get a symmetrical setup for our vehicle. So we'll tweak this and play around with it, but we want to get the other wheels in. We've set the values, so we should be approximately okay. So this front left, I'm gonna duplicate it. I'm gonna just do Control D to duplicate, and that gives me my other wheel. And then I'm going to go to the transform for that new wheel, and I'm going to make it negative on the X. So you'll see that puts it across the other side. Now I'll need to rename this one too. So if I say it's the front right wheel, and we can get rid of the number 2. And then with both of these, I'm going to select both by holding Control while I click them, and then I'm going to do Control D again, which gives me 2 new wheels. And I'm just going to set the transform of both those so that it's the negative in the Z, so it's negative 0.85, so we have a symmetrical kind of vehicle right now. And obviously we'll rename them. So we've got the front, so no longer front, it's the back left wheel, and for the other one it is the back right wheel, and we can get rid of the number 2. So we really want to start testing this. So this scene, we're going to add in our camera, so just add a camera node in there, and we'll just move this camera, actually just so we get it right, I'll move it to the other side, set the transform rotation to 180 so that it's looking the other way, just move it up. So it should be looking behind the car, and it should be looking sort of approximately down in the direction of the car. So just turn it down a little bit and I can click this preview to see what it looks like. So closer a little bit, I reckon. And then if we hit this play scene, we should see that the car will drop down and through the ground. So the ground needs its static mesh as well. So click on the mesh, click create try mesh static body, and it'll just do this for you. And then we can try that again, and hopefully we'll see the physics reacting. So it kind of bounces up and down. That's the damping value that does that. So if we click, if you want to change all of the wheels, you can just shift click. So click the top one, shift click the bottom one, select them all, and then we can change the damping value up. So again, if you hover, if you look in the documentation for these ones, this is the compression and relaxation. These values should be much higher. So if I leave the compression at 0.83, but the relaxation, I'm going to make that 0.98. And you're welcome to look up the vehicle wheel documentation as well, and you can have a little look, but you can tweak these values as much as you like. So let's try that and we'll see. So it still bounces a fair amount, so let's put this one back down to maybe 0.8, and we'll put this one up to the 0.98, so really close to full damping, and it hopefully will be a lot less bouncy. So it's still a little bit bouncy, and again we'll maybe make this 9.5, so put these values up and give it a test. Okay, so it's not too bad. It starts to slow down a little bit. And again, as I said, I've played around with these values quite a bit, and it's not, you just have to kind of like play with them to get the hang of it. And yeah, while I'm here, just mention as well about the mass of the vehicle body. So it gives you a default mass of about 400 kilograms, which is light for a car, but you can change that too, and it will affect the momentum and everything as you play around with this. Alright, we'll write the start of our code and then we'll tweak this vehicle a little bit more. So we want to inherit from the vehicle body. I'm just going to click the plus over here. I'm going to leave it in the default location for now. I can tidy them up a little bit more. Rather than call this VehicleBody.gd, however, I am just going to call it car, and I'm going to click create to create this. So this will extend from vehicle body. Just going to delete everything here. And all we really want to do is we want to use what's in the vehicle body class to be able to make this vehicle move around. So if you control click on it, you can read some of this description. You see it's got really cool things like being able to set the engine force, brake force and steering, and that's kind of all you really need, and it's super simple that it's done in this top level. So we'll go to the project settings and go to input map. We need to get our mappings done. So I'm going to have a forward, I'm going to have a back, I'm going to have a right, and I'm going to have a left. I'm going to set each of those up. So I've click on the plus, choose the key, and for forward I'm going to say W. For back I'm going to say it's a key again, and this time it's S. For right is another key, and I'm going to use D. And for left is another key, and I'm going to use A. Alright, so keep it really simple. We're just going to go into the physics process. So I'm going to say, I'm going to create this physics process, and we're just going to get the basic input. So I'm going to say that steer is equal to, and I'm going to use input.getAxis. This will take in the left and then the right, and it will give us a value between -1 and +1, and we'll be able to set the steering of the vehicle body. So the value we're looking to set is steering, which is part of the vehicle body. So I'm just going to say that steering equals, and then we'll just say steer, and that's as simple as it is required. And the next thing would be the acceleration. So I'm going to do it really simple too, and I'm just going to say acceleration that equals to, and I'll use the same as I did before, this get axis, and I'm going to use back, comma, forward. We're not going to change any values right now, and what we need to do is just quickly check on vehicle body. So what we want to set is this engine force, so we can set the engine force based on that acceleration. So go back to here, and we'll just say engine force equals, and we'll say acceleration. These values will be very, very small, so it's probably a good idea to multiply them by something. So this acceleration, this will be like the maximum torque that you can create. So let's try 100. I'm sure that can't go wrong. And with the steering too, this will be between -1 and 1. And it turns out that it's kind of okay. You can multiply that by 1 right now, and then we can just tweak this up and down depending on how much you'd like to steer. And the last thing that we need to do before we can test this is we need to just make sure that, because we're using the vehicle body, that we've set these wheels up so that they do the right job. So if you look at this vehicle body traction, the two front wheels, if I double click on each of the front wheels and go to vehicle body motion, they're set as use as steering, but we need to make sure that the two back wheels, and I've just double selected those ones, so shift click them, so we don't say use as steering, we say use as traction, and from that point on we should be able to test it. So if we hit the play and drop down into the game, you'll see that we're able to move forward and we're able to steer. I've actually got the steering the wrong way around. It's easy fix, and it's a mistake that I make fairly regularly. So jumping back to the script, so because it's the wrong way around, the steering, we've got this left comma right, we just changed that to the right comma left, so that we've got them the other way around, so right comma left. The acceleration is the correct way around. The steering seems to be a little bit too much, so I'm going to change that value to something like 0.4 so it doesn't steer quite as much. We should probably visualize that. So we'll create some simple wheels for now, just so we can visualize that. And this, the acceleration seems to be a little small, so I'm just going to make that something like, I don't know, let's make it 500. And we'll just test that again one more time. So we'll see that now the steering is slightly less, and the acceleration is probably a little bit too much. It'd be nice if we were able to see what was going on with the wheels. So let's actually set that up, and I think we'll need to change that damping too. So just one little change. If we change the damping, so I've selected all of the vehicle wheels. So select the vehicle wheels and set the compression to 1.9 and the relaxation to 2. You get a much nicer result. I know the documentation says you're not supposed to set it up above 1, but just if you see now that what happens is it doesn't bounce more than like 1.5 bounces rather than continually bouncing. So it turns out you can put these values up as much as you like. I left the stiffness around about 52. So let's actually create something for the visualization of the wheels right now, just so we can see what's going on, and then it'll make it easier for us to make changes. So the wheels radius is 0.4. So what I'm going to do is I'm just going to create a mesh. So I've got a mesh instance again. So if I just double click mesh instance, and I'm going to choose the one that fits the shape of a wheel most likely. So this cylinder mesh right now, and it's totally the wrong size. So let's just click on it so we can change this. So I want it to be 0.4. Both top and bottom, because that was the radius of our actual wheel. That should match. I want the height to be something pretty small, so I'm going to say, I don't know, like 0.3 or something like that. So it looks a little bit like a wheel tire, and it doesn't need nearly as many segments, so I'm just going to change that down to 12 and leave the rings at 4. The cool thing about the way that this one works is we don't need to stuff around it. I know it's facing the wrong way around, but what we can actually do in here is we can set its transform down here, and if we look, it's the blue Z axis, so we want to rotate around 90. So I'm just going to say 90 degrees. That was the position. That's the rotation that I need, so 90 degrees around the Z, and that puts it in exactly the same position and radius as the wheel collider that we've got there, the vehicle wheel. So let's just quickly test it. I think there should be a different color as well. So if I just find the material here, make a new spatial material, click on that and set its albedo to black, and then it looks a little bit like a car wheel, and then we'll just quickly test that. So what you'll see when we test this is that this reacts to the key presses, and it'll actually spin around too, and it gets moved around by the vehicle wheel. So as the suspension goes up and down, you'll see that it actually moves as you'd expect. So we'll do that, just duplicate that to all of the other ones as well, and that way you'll have some visualization for your vehicle. So we'll just copy that one, click on that, and choose paste. So again, just use Control V, and we've got 4 wheels ready to go. So I will go back to the script in here, because one of the main issues is this acceleration is so high that we actually wheelie. So I'll change this value down a little bit, and we'll just go back into 3D. We'll just test this again. So hopefully it won't wheelie. So it doesn't wheelie as we accelerate. But if you start accelerating and you keep accelerating, what will happen is it will eventually get faster and faster and faster and faster. So there's no damping on this. It doesn't seem to want to slow down. So we need to kind of think of a smart way to be able to fix that too. So let's tidy this code up just a little bit. So let's create some variables for how much steer we've got. So we've got the steer equals 0, so we don't need to define it again inside of there. We also want to set sort of some sort of maximum torque that we would like. So I'm going to say that the maximum torque is going to be something like 500. And what I'm going to do is I'm going to set a maximum RPM. Max RPM value as well. So I'm going to say that the max RPM is going to be 500. And what we're going to do is we're actually going to read the value of the back wheels before we apply any force to those back wheels, and we're going to individually apply force based on some sort of function, some mathematical function, so that we don't get the back wheels to go beyond a max RPM. This is kind of simulating mechanical drag that you get in cars, so we don't have to add drag to the rigid body. We just have some sort of drag added to the wheels so that they don't accelerate beyond a certain RPM. So just after we get the acceleration, let's find out what the RPM is of the wheel we're targeting. So we'll just say var RPM equals, and then we'll need to the absolute value, so you use the abs keyword there, and then we'll just drill down into the wheel that we're looking for. So let's say the back left wheel, and we want to say we want to get its RPM, so we use the function get RPM, and that will return the RPM of that back wheel. And then we want to do some sort of calculation and set the engine force of that based on what its current RPM is, so that when its current RPM is at maximum RPM, you want to set the acceleration to 0, and then when it's the current RPM is down at 0, you want the acceleration to be full. So the way we'll do this is we'll just look at this back left wheel again, and we'll set its engine force to be equal to the acceleration that we would like, so the current input for acceleration times the maximum torque that we would like, times, and then we need 1 minus, because we need to negate this, 1 minus the RPM divided by the maximum RPM that we would like. So it's a little bit confusing, but this will end up with, as I mentioned before, when the current RPM is the maximum RPM, then we'll get a value of 0, but when the current RPM is 0, we'll get a value that's equal to the maximum torque. So it just works, so you just kind of have to trust me on this one. We also need to make sure that we do this for the other one as well, so the other back wheel as well. So to save my typing, I'll just copy and paste, and we'll change the bits that we need. So it's not the back left wheel that we want, it's the back right wheel, and we're still getting the RPM, and we want to have the back right wheel's engine force set to that calculation. Now that we've done that, we don't actually need to set the engine force there. We should be able to just have this work. So because we've already defined the variable RPM, we don't need to redefine it when we do it here, so we can just say RPM. We're only going to use it temporarily to set that value anyway. So we'll go back to the 3D view again, and what I want to do so I'm able to test this is I just want to take the camera and put it as a child of my car. That way it'll move around when the car moves around. I'm also going to rename my top level object there to car, and just have a little look to see where my actual camera is, and move it into position so that I can actually see. So let's look at that. So we should be able to see the car, and we should be able to see the suspension working as we move around in the scene. So I'll just quickly test this to see how it works. So we can see the suspension going up and down. We see that the car actually does accelerate and it turns. It'd be nice if we were able to see something. I think I'll actually show you how to do that as well, because it's kind of cool. So I just did a quick Google search. I wanted some sort of grid texture type thing, so I found something on opengameart.org. It's Prototype Texture Pack by iPoly3D. So I'm just going to save that one image. I'll just call this grid, and stick that in my pictures. So I just want to take that that grid that I got downloaded. I'm just going to drag and drop it into my project here. I'm going to create a new spatial material, a very special one that I can use in order to make the ground much cooler. So I'll just click on the ground right here, just go down to where it says materials, and change that into a new spatial material. And there's a few fancy things that we can do to this new material to add this grid texture so that it works perfectly no matter how much you resize things. So if we find the albedo and we drag our new grid texture onto here, you'll see that it gets stretched horribly across the whole thing. So just go up into flags for this material where it says triplanar, click on, and if you scroll all the way down to the UV1 as well for this material, and also tick triplanar, and I'll just repeat this multiple times across the whole of the shape that we have for our ground, which makes it an awful lot easier for us to see the speed that we're moving and make sure that we're able to test this quite a bit. So I've made my world 50, so it's a little bit bigger, so I can see that it's accelerating as it goes, and it does tend to not accelerate beyond the speed that we have set it to. So it's looking like it's working pretty well so far. So just to, you can tweak these values as much as you like, but what I'm going to do is just drop this down a little bit so that so we don't get the wheelie when we start, and then we'll just fix the steering so that we get that a little bit smoother too. That's pretty easy. We just want to kind of lerp rather than directly move it straight to the value. So all we'll do is we'll just do lerp, and we'll just say that we're going to go from the current steer value, which is why we stored the steer value up the top, to the input value that we would like, and we want to make that value times, we'll do the calculation here rather than down here, so we're basically taking it out from there, and then we'll say how quickly we'd like to do this. So I'm just going to hard code a value of 5 times delta, so this is just how quickly it will go to that. So yeah, you can tweak this value. If you need it to move faster, then you make this value higher. If you need it to move slower, you make the value less. And then we can just say that the steering equals steer, and that's exactly it. So if we test this now, what we should see is that as we steer, it will slowly move to the value of 0.4 rather than move really quickly. And the torque now, we don't get quite the same vicious acceleration when we start taking off, but we will still get to the maximum RPM of those back wheels, so we'll get to the speed that we've set for that value. So I just chucked a few fun little cubes in there just so we could drive it around. So that's the first part of the tutorial. Hopefully that's all kind of made sense. The VehicleBody node is a pretty cool thing, and everything seems to work pretty well once you get those values set up the way you like them. And obviously it's just a physics thing, so you can tweak them as much as you like, but it works pretty well, and hopefully you're enjoying this new series. And I've got one more where we add in the chase camera as well, so you don't get this whole this horrible camera angle that doesn't have any smoothing to it. So yeah, stick with the series, and I'll see you in the next one.